Today I'll be showcasing the exciting process of programming a drone using Python in just under 5 minutes. So let's dive right in and get started. First, go to Amazon, search for DJI Tello drone, select this drone and order it. Once the drone is delivered to you, turn it on by pressing the power button on the side and wait for the light to blink steadily with an orange color. Now go to your Windows or Mac device and select Tello from the Wi-Fi list to connect. Open your favorite Python IDE. I'll be using PyCharm for this demonstration. We need to install DJI Tello and PyInput. We'll use DJI Tello to control the drone and PyInput to monitor keyboard keystrokes. In PyCharm, navigate to File, Settings, Project Interpreter. Click on the plus button, search for DJI Tello and install it. Next, search for PyInput and install it as well. In the code, import Tello from DJI Tello, keyboard from PyInput and key from PyInput.keyboard. Now let's create an instance of Tello and call the connect method on it to establish a connection with the drone. To test the connection, we will check the battery level by calling the get_battery method on the Tello instance. Let's run the program now by right-clicking and selecting Run Drone Control, which is a program name. As you can see, the battery level is at 64%, indicating that we have successfully established a connection with the Tello drone. Now we are set to write a function to control the drone programmatically using the keyboard. Let's declare an onPress function with key as the parameter. Attach this onPress function as a listener to keyboard clicks, which can be done like this. In the onPress function, let's monitor various key presses and send commands to control the drone. Pressing the page up key will initiate the drone takeoff. We will use the takeoff function of Tello for this, and in send_rc control we'll pass 0 for all the arguments to make the drone hover in the same place. We'll explore these arguments in detail when we write the code to move the drone left, right and forward, backward. Pressing the page down key will initiate the landing process. We will first use send_rc control and pass 0 for all arguments to hover the drone, and then utilize the land function of Tello to safely land the drone. Now let's delve into the arguments passed in the send_rc control. The first argument is left-right velocity. The second is forward-backward velocity. The third is up-down velocity, and the fourth is yaw velocity. We will set the velocity constant to 10. Now we will monitor the right arrow key press to move the drone right. As previously discussed, we will begin by setting the velocity to 10. Following that, we will use the send_rc control function on the Tello instance, passing a positive velocity of 10 as the first argument. Next, we will monitor the left arrow key press to move the drone left. Again, we will use the send_rc control on the Tello instance, but this time we will pass a negative velocity of 10 as the first argument. Moving on, the up arrow key press will command the drone to move forward. We'll utilize send_rc control on the Tello instance with a positive velocity of 10 as the second argument, which is the forward-backward velocity argument. Likewise, pressing the down arrow key will prompt the drone to move backward. Applying send_rc control on the Tello instance will pass a negative velocity of 10 as the second argument. For ascending, we'll respond to the W key press by instructing the drone to move up. Once again, send_rc control on the Tello instance will be used, and a positive velocity of 10 will be sent as the third argument, which is the up-down velocity argument. Similarly, upon pressing the Z key, the drone will be commanded to move downward. Send_rc control on the Tello instance will be invoked, and a negative velocity of 10 will be passed as the third argument. Now let's test our code by right-clicking and selecting Run Drone Control.